So in section 6.7, we are going to be looking at direct and inverse variation. Direct variation is very similar to like equations that are in slope-intercept form that have a constant rate of change. And then indirect variation is quite literally the opposite. Today we're going to be only working with direct variation. So here's the notes that we have. That, like I said, it's like a screenshot from the textbook. And I'm just going to read them and kind of show you what everything means and relate it to what we already know, which is kind of like a different name for it. So in the problems, you're going to be seeing something like y varies directly to x. So you're looking for the word directly, and when you see the word directly, then that means that your equation is going to be looking like it's in slope-intercept form without the intercept. So like if you remember, slope-intercept form was y equals mx plus b. This here is your slope, and then this here is your y-intercept. The formula that we're going to be using in this case is y equals kx. So it's very similar in that there is no y-intercept other than just the starting point 0, 0. So it's the starting point will always be 0. But then they call the k something else. So instead of calling it the slope, in this section they call the k the constant of proportionality. So constant of proportionality, just a fancy way to say the rate of change. Because it's constantly the same rate, they like to call it the constant of proportionality. So when we do the web assigned questions, you'll see questions asking for that. It's basically the slope. And your equations will always look like this. It'll be y equals whatever the slope, aka the constant of proportionality is, times x. So in this first practice problem, they are telling us that the total revenue in dollars obtained from selling X ice show tickets is directly proportional to the number of tickets X per sold X. Then they're saying when 10,000 tickets are sold, the total revenue is $142,500. They want us to find a mathematical model that relates the total revenue to the total number of tickets sold, and then they want us to answer a question based on that. So in order to do this problem, the first thing I would want to do is just look to make sure that they say the word directly, because there is a different type of equation that's inverse. So because they say directly, I know that my equation is going to look like this. Now, in the problem, they are telling us to use R for revenue instead of Y. You can do that, or I'm just going to say that Y is equal to the revenue, and they tell us that X is equal to the number of tickets. So this problem is all about how much money you're making, that's what revenue is, versus how many tickets you're selling. And in order to create an equation, we basically need to figure out what the constant of proportionality is, which in this case is the cost per ticket. So it's like a bunch of fancy words for something that we already know how to do. So to figure out the constant of proportionality, we would have to use these two numbers. And the total revenue was $142,500 for 10,000 tickets. And what would we do with these two numbers?
Y would be the 142,500.
Yeah, so we can replace the $142,500 in for Y since that's revenue. And similar, we would also then replace the 10,000 in for X. And if we want to find the constant of proportionality then, we would solve this equation, and we would solve it by doing what? Yeah. So we're going to divide to solve for K by 10,000. And when we do that, we're going to get 14.25. Okay, so that means that this is the constant of proportionality, and therefore I can create my final equation. Now that I've solved for k, I know that the equation is y equals 4.25 times x. The constant of proportionality means that it's $14.25 per ticket. If this whole problem was reworded a little bit differently, I feel like it would make so much more sense, but with direct variation, I feel like the problems are not written normally like we would usually see, so it's confusing when they say, you know, directly proportional and find the constant proportionality and whatnot. So basically, once we found this, which is like the slope, which is the rate of change, which is also how much it costs per ticket, now we will answer the question in letter B, which is asking us to find the total revenue obtained from selling 12,000 tickets. So for letter B, what would we do with the 12,000? Yeah. So we're going to multiply it by the 14.25 to figure out what y is equal to when x is equal to 12,000, which will basically tell us how much money we're going to be getting when we sell 12,000 tickets. So go ahead, use your calculators and solve that.
I have a question.
Yeah.
So we're doing like right. So this one is going to be
Yeah. All right, what do we get for the final revenue? Perfect. Okay. So easy enough for that one. The next one's a little bit more difficult. So the next one is going to be about something looks like in physics. So Hooke's law for springs states that the distance a spring is stretched or compressed is directly proportional. So I see directly proportional. I know that means I can create an equation that looks like this. To the force on a spring. A force of 20 pounds stretches the string 5 inches. And we want to create a mathematical model that relates the distance the spring is stretched to the force applied to the spring. So here's where things get confusing because they don't tell us what x and y represent. We have to kind of figure it out from the problem. So we need to replace 20 and 5 in for x and in for y, but we have to make sure we understand which one does represent x and which one represents y. So in this case, the way that they say this right here, the mathematical model that relates the distance the spring is stretched to the force applied will help us figure out which is y and which is x. So the first thing I did with this problem is I wrote a proportion, and the distance the spring is stretched would be where it says stretches a spring 5 inches. So I wrote here 5 inches first because that number represents the distance the spring is stretched. And I related that to what we wanted to relate to, which is the force applied to the spring, which was 20 pounds of force. So what I'm doing right now is I just created a proportion just to show that for every 5 inches a spring is stretched is because of 20 pounds of force. And sometimes that just helps me figure out what I'm supposed to do with the x and with the y here. Because for this problem, to find the constant of proportionality, we could do a couple different things. We can create an actual proportion and solve. We can put these numbers in for y and for x and solve that way. So here's the one way we did, just like the first problem. So if we are trying to relate the distance a spring is stretched to the force, that means that this first thing would be y, and this second thing would be x. So when they say relating something to something else, the first thing that they give you is going to be the y, because that's going to be affected by x. So if we were to use the same model as before, what I would do is replace 5 in for y and 20 in for x, because the way that they have the the problem written out. They're basically telling us that y is going to be equal to the distance, and x is going to be equal to the force. They don't tell us that in the problem. We have to pull it out from the problem, which I think is the hardest part in this problem, is figuring out what x and what y is. But as you think about it, it does make sense. Like if you're putting force on a spring, the distance it stretches depends on the force. Vice versa wouldn't make sense. The force doesn't depend on the distance. So that does make sense once you really think about it. So if I take then 5 and replace it in for y, and I take 20 and replace it in for x, to solve for the constant proportionality, I would divide both sides by 20. I can simplify 5/20ths into 1/4. And that means that 1/4 is equal to the constant of proportionality. So then altogether, my equation would be y equals 1/4 x. I feel like this one was a little bit more difficult because the constant of proportionality ends up being a fraction. And also because they don't tell us what x and y is, you have to figure it out on your own. And then for letter B, it's asking us to figure out how far will a force of 30 pounds stretch the spring. So what we would do here is then use our equation, and we know that y is distance. That's what we're looking for in this problem, and x is force. They tell us that it's 30 pounds. So I would take the x and replace it with 30 and figure out what the distance is. And what did we get for that? What's 1/4 times 30? Is it 7.5? Okay, so that would be 7.5. In this case, it would be 7.5 inches. All right, and then the last thing we're going to do is on the next page, because this is the last thing with direct variation. And this last problem here, it just gets a little bit more confusing with the direct variation, because now we have like this added thing about like to the nth power. So in order for us to complete problems with this, we have to see in the problem that it says that y varies directly as the nth power of x. And the equation looks kind of similar. We still have y equals the k times x, but now we have this new thing here that we are going to be seeing like a power of some sort. So instead of it just saying y equals k times x, it could say y equals k times x squared, or y equals k times x to the third power. So in this problem, they tell us the distance a ball rolls down an inclined plane is directly proportional to the square of the time it rolls. They tell us during the first second, a ball rolls down a plane a distance of 6 feet, and we have to figure out the mathematical model that relates this, the distance traveled to the time. So because they tell us this in this order, that means that this is going to be directly related, meaning that distance is going to be y and time is going to be x, which makes sense. Because if you think about rolling a ball down a hill, the distance that it rolls depends on how long it's rolling for. So in proportions, that would make sense that the y variable is dependent on whatever x is, because the distance depends on whatever the time is. Only thing that's different here is that they say that it's directly proportional to the square of the time it rolls. So that's where this comes into play. So to create a mathematical model, they tell us that the first second, which is going to be your constant proportionality because the plane is the same incline. So in 1 second, they say it rolls 6 feet. So that means that that 6 is going to go in the spot of k. They give us the k. So it's going to be y equals 6 times x. And then what's different about this is that they tell us that it's proportional to the square of the time. That means instead of x just being regular time, it needs to be time squared, because taking the square of something means take it and multiply it by itself, which means raise it to the power of 2. So creating these equations, you really have to look closely at the wording of the word problem because it'll tell you what to do, but you really have to read closely. Because the first time I looked at this, I was like, I don't see where I would have an exponent, and I was like, oh, I see the word square, I missed it. So then after I create my mathematical model, then it's time for me to figure out how far the ball would roll during the first 2 seconds. I know that y is representing distance, and x is representing time. So if I want to figure out how far it will roll in 2 seconds, I'm going to replace 2 in for x. And just make sure you're using the order of operations correctly. When you are using the operations, you would have to do 2 squared first, and that's 4. And then 6 times 4 is 24. You would not do 6 times 2 and then square it. You would have to do 2 squared first, then multiply by 6. That means it would roll 24 feet.